as we dive into our food unit, we need to just kind of stop and think about food. Again, the basis of all our food comes from plants. And so really, what do plants need? So if plants stopped growing, we would be dead. There wouldn't be oxygen being produced and things like that. But also, we wouldn't have food. So in order to have enough food to feed the world, to have food for us, what is it that plants really need? And so I know you're sitting there really excited thinking, well, of course, plants have to do photosynthesis. So one thing they're going to definitely need for that is they're going to need the sun. And they take in CO2, carbon dioxide, to do photosynthesis. So is that enough? Could I just have a plant grow on a bare table? If I have it give it sun and CO2, will that be enough? And you're probably thinking, well, no, there's some other stuff, probably some water. And then you might be thinking of, with water, well, there's other things. In fact, I remember some of the nutrient cycles, we would talk about how does a plant get its nitrogen, and we would say it had to be dissolved in water. And so the water, the nitrogen, the phosphorus, the potassium are the nutrients. And I'm going to write nutrients, but I'm going to write nitrate, phosphate, you should know all of those, and then K, okay, is one we haven't really seen so much, but they'll often talk about the NPK are some big nutrients that plants need. There are others, but those are some of the big ones plants need. And so would that be enough? Could I have this a plant grow on this bare table, sitting in water with a lot of nutrients, sunlight, and CO2? Well, still probably wouldn't, because what else does it need? It needs somewhere to grow in, and so soil. It needs soil. And then the last thing, which we often forget, is you actually need a seed for a plant to grow. So those are kind of the 6 things. So what does it take to produce food from plants? We need a seed or some type of starter. It needs a place to grow in the soil. It gets its carbon from the air and carbon dioxide, doing the process of photosynthesis. Needs water, probably from that water cycle, and it needs those nutrients. So there's our nitrogen and our phosphorus cycle. So again, a lot of this stuff ends up being really good review for us. So that's where a plant, or things a plant needs to produce food. So then if you look at the next page in your notes, you'll see here, thinking of CHONP. So what is all of this? Again, this C, again, we got to know our symbols. C is for carbon, H is for hydrogen, O is for oxygen, N is for nitrogen. The confusing ones, P is for phosphorus. Again, that's our one cycle. K is potassium. Those are the 2 confusing ones, but P again is our phosphorus cycle, and we talk a lot about phosphate. S is sulfur, the sulfur cycle, and Ca is calcium. So thinking about all of these, we need to think about where does a plant get those, because these are, again, these macro meaning large here. So these are pretty big nutrients that the plants are going to need in larger quantities. And so where is a plant going to get them from? So from where does an autotroph, again, autotroph, plant producer, get its carbon from? Well, it gets it from the air. In what form? CO2. Why does it need it? To do photosynthesis. And well, it's associated with the carbon cycle. So now what I'm going to encourage you to do is to pause this video and try to fill in as much of this page as you possibly can, because this should be pretty much stuff you already know. It should mainly be review. Second semester is new stuff, but it's a lot of review and making connections. And the more, again, remember we've talked about retrieval practice, the more you quiz yourself on things and you're making yourself try to recall it, the more it sticks in your brain and the more you can make connections. And so much of what we need to do is make connections. So pause the video and try to fill in this page as much as you can, and then restart the video and then check your answers with me. So go ahead and pause. welcome back. I hope you've been able to fill a bunch in. H, okay. Basically, the H is going to come from water in the H2O, okay, which is the form of H2O. Why do they need it? Well, H is a building block, okay. So when things are organic, they're carbon, and then it's just a building block of it. So it's, I'll just say a building block. I'll probably put that for several of them. And again, it's associated with the water cycle. Same thing for oxygen, comes from water, mostly. Again, there are other places and things that can, in doing respiration, takes in oxygen, but we're gonna mainly say it's gonna get it from water cycle. Again, oxygen is a building block in lots of different things, and this again is associated with the water cycle. N, where does it get it from? It gets it from dissolved in water. Okay, in what form? Nitrate, which is that NO3 minus 1. Why does it need it? Okay, it's often it needs it. So I'm gonna again put it's a building block. So I keep putting down it's a building block. What does that really mean? It means it needs it to build more of the plant. And so if I don't have enough nitrate or enough nitrogen in particular, the element nitrogen, it's gonna stop growth. That's that whole idea of the limiting reactant. Okay, P, I'm gonna put DIW, remember that's my dissolved in water. It's gonna be phosphate, PO4 minus 3. Again, I'm gonna just put BB here for building block. Essentially apart. So again, this whole formula up here, all of these are building blocks. If you don't have some of those, the plant won't grow, it'll stop, which is again, or stop growing. Again, that whole idea of limiting reactants. And typically, N and P are the ones that are limiting in fresh and in salt water. P in fresh and in salt water. And this is the phosphorus cycle. Okay. So where does an autotroph get this? Again, typically dissolved in water. In what form? It's going to be in the form of the potassium ion, or K+. It is a building block. We don't really have a cycle that we've associated with it. So there are cycles, but I'm just going to leave it blank or not really worry about that. S here is also dissolved in water. The form is sulfate. This goes back to the sulfur cycle. Sulfate is a building block. There's a disulfide bond in some amino acids, the building blocks of proteins, and it is associated with the sulfur cycle. All right. Lastly, calcium typically will come from soil or just, but it will be in the form of dissolved in water. It also can be like limestone. Will have a lot in it, but what will happen is it's an ion, it must dissolve in water. So when I put down limestone here or soil, it could be in that, but for the plant to take it up, it has to dissolve in water and become an ion. So it's going to be the calcium ion here, and it's a building block. Cell walls are going to need that calcium in it. So super important for that calcium, and we're not even going to worry about any of the cycles or anything with that. But it is like the calcium is associated with like hardness. When we talked a little bit about the water pollutant of hardness, we didn't talk much about that, but again, the hardness of the water supply can be related to that. Also, well, yes, hardness can be related to that. So that is the first 2 pages, kind of the intro, mainly a lot of review, but starting to make connections. Thanks.